I have already shared that these questions are important not only from viewpoint of the board examination, but also for JEE Mains. In this question number 2, the capacitance of a capacitor is C naught. Here is a capacitor of capacitance C naught. It is connected to a battery of voltage V. Now, according to the problem, while battery remains connected across the ends of the parallel plate capacitor, a dielectric is introduced, and we are supposed to investigate these 4 options. One of them is correct. So before I do this, I would like to discuss various points associated with this circuit only. The capacitance, the first point happens to be the capacitance of this parallel plate capacitor is given by the expression C naught is equals to epsilon naught A by D. The second point is the charge on this parallel plate capacitor Q naught, that will be equals to C naught is to V. C naught happens to be the capacitance of this parallel plate capacitor given by this expression. And the third point, electric field in between these two parallel plate capacitor is given by the expression E is equals to V by D. If you want, you can also write this to be sigma by epsilon naught or Q naught by epsilon naught A. When the capacitor is filled by dielectric of dielectric constant K while this battery remains connected, let's see that how these 3 factors changes. So here is the parallel plate capacitor. In fact, the same capacitor connected across a battery, and the dielectric has been introduced. Here is the dielectric. Let's assume the value of dielectric constant being a small k, and in this case the new value of capacitance will be given by C is equals to K epsilon naught A by D, and you can check this within these dotted box is same as C naught, so this is equals to K times C naught. So this suggests the capacitance of this parallel plate capacitor increases by the factor K. The second point, the charge on this capacitor with the dielectric Q, this is equals to how much? C is to V, and the value of C is equals to K into C naught. This is K into C naught, and this V is V, but this C naught is to V is same as Q naught. So this can be rewritten as K is to Q naught. So the charge on the capacitor increases by the factor K. Is it right? The additional charge will be Q minus Q naught, and this is supplied by this battery. Anyway, this has not been asked. Now the third point, the potential difference across the capacitor. The potential difference across the capacitor is maintained by this battery. So the electric field, the new value of electric field E, let's put this to be E naught, is equals to value of V has not changed, V upon even the value of D, the separation between the parallel plate capacitor has not changed, and that is why this value E is same as the original electric field E naught. Further, if you want to explore using this relation, so it's okay. So if we use this value, E equals to Q by K epsilon naught A. You see the value Q naught will change to Q, and epsilon naught is always replaced by K epsilon naught in presence of dielectric. Now substitute value of Q. This is equals to K Q naught by K epsilon naught A. This K and K will cancel. So the new value of electric field E is same as Q naught by epsilon naught A, and which happens to be same as the original value of electric field. Now see these 4 points. The electric field between the plates of the capacitor rises. This is false, as we have seen that the value of electric field remains unchanged. The second point, the potential difference between the plate false. This is again is an incorrect statement, and the reason being the potential difference between the plates is maintained by this battery. Third point, the total charge on the capacitor increases. This statement is correct because the total charge increases by the factor K. And the fourth point, the ability of the capacitor to store charge decreases. This is a false statement because from here we learned that the capacity of storing charge increases by the factor K.